Pechay and his friends.
Hi there, we're back, and for today, we are going to talk about population dynamics through a mind map. As always, let's start with the basics. What is a population?
A population is a group of single species or interbreeding organisms living in the same space at the same time.
There are two types of population. One type does single-time reproduction known as semmalparous, while the other one is called heteroparous because they perform a repeated reproduction process.
We also have what we call demes. Demes are local populations of sexually reproducing organisms that involve a shared gene pool. Prolonged isolation of this local population may give rise to new species or subspecies.
There are also two types of boundaries of population. Boundaries that are naturally occurring are called natural boundaries. Examples of these boundaries are distinct herds for animals and political boundaries for humans.
The other type of boundaries that are socially made are termed arbitrary boundaries. Fishes in the oceans perfectly exemplify this type.
And for the last part of population basics, in the mind map, we have unitary and modular types of organisms. Unitary organisms are distinct in form, as you can see in the diagram, where dogs are shown in different colors and figures.
Modular organisms, on the other hand, are individual units that remain the same in forms. An example of this is a clonal colony that originated from a single ancestor.
Okay, now that we're done with the population basics, we will be moving with our second main point, which is the population dynamics. Population dynamics is the area in population ecology that is concerned with factors influencing the expansion, decline, or maintenance of populations.
Population ecology has living and non-living factors, which influences the size and density of a population. Hence, this may lead to the expansion, decline, or can be maintained throughout time. This also includes demography, which pertains to the study of vital statistics of a given population and how it changes over time.
Also, there are demographic factors that affect the population. These are the natality or birth and immigration, which adds to the population density of an area, as well as the mortality or death and emigration, which causes decrease in the population density.
Another is the distribution of an organism from one place to another, is the dispersal. This is caused by the population expansion that results in either increasing or decreasing of a population.
Now that we're done with the basics and population dynamics, we will now talk about population growth. Biotic potential and carrying capacity are the two salient terms we must take note of in population growth.
Biotic potential is the property or capacity to multiply, and it is influenced by sex ratio and age distribution. On simple terms, it is the maximum reproductive rate of an organism.
Carrying capacity, on the other hand, is a number of organisms that a region can support without environmental degradation.
Carrying capacity changes with the changes in the environment. Limiting factors determine the carrying capacity of an environment for a species. And these factors are of two kinds. The first factor is density dependent, and the second one or the other one is density independent.
The first limiting factor is termed as a density dependent because it depends on the population densities. This includes abiotic factors such as a competition between organisms, predation, parasitism, or disease, and so on.
The second factor does not depend on the population densities, hence it is termed density independent, and that includes abiotic factors such as natural disaster or unusual weather.
And for the last main point of our mind map, we will be discussing the visualization of population through graphs. So, how do researchers visualize the population?
There are two growth pattern models used to visualize populations. First is the exponential, which is the J-shaped model. This pattern has a continuous increase in population with the per capita growth rate, or the R, doesn't change even if the population expands.
However, the resources are also limited and can be depleted. As a result, R will get smaller as it reaches the approximate maximum size or will create a plateau, hence creating another growth pattern called logistic or S-shaped.
Next are the visualization types that include life table, survivorship curve, and the age sex structure pyramid. Life table provides clear and systematic representation of birth and death rates of a population at different age stages.
Survivorship curves are similar to life tables, where they both visualize the number of individuals that can be anticipated to survive throughout time, but this time it's in a graphical presentation. There are three types of survivorship curves. Type 1 portrays individuals that have a high chance of death as they reach adulthood. An example of this are humans.
In type 2, organisms die equally at each age period. This type of curve can be found in bird species. And lastly, the type 3 survivorship curve, which is evident to trees and most fishes, is a type of curve where there are only few organisms that can survive their younger years.
Lastly, the age-sex pyramid is a groupie of a population over time which shows how people are divided into age and sex groups.
Population growth stages is another strategy to visualize population. It consists of four different phases, namely lag phase, log or exponential phase, stationary phase, and the death or decline phase.
In the lag phase, the population is small, hence, the resources are abundant. In the second phase, which is the log or exponential phase, there is a rapid growth in the population and a fast utilization of resources.
While in the third phase, known as the stationary phase, it has already reached its carrying capacity, therefore it has zero population growth. The last phase is known as the death or decline phase, where the population has already exceeded its carrying capacity.
And that's it for our discussion for today. We hope you all learned something. Have a nice day!